Alright, so my name is Nicholas Vandewally, and I'm going to try to explain a little bit about electricity. I'm going to get sort of in-depth a couple of times, and so this is going to be broken up into various segments. Over the course of today, I would like to get through the entirety of what is electricity. I'm going to go over what exactly it is, I'm not going to go into the deepest levels because electricity is very, very complicated, but I will give you what my understanding of electricity is. I'm going to explain how we use it, and I'm going to explain how not to die while using electricity. Because, as you know, it's easy enough to be electrocuted by, pretty much anything. So, well, not pretty much anything, but everyone's heard horror stories about lightning bolt strikes and everything else. Infants sticking their fingers in electrical sockets, all of that stuff. I don't want anyone who watches this video to die after playing around with electricity for a lot of reasons. Not going to go into them here. So, let me start by talking about what electricity is. Now, first of all, the word electricity comes from the idea of electrons. Now, electrons, as anyone who's taken chemistry will be able to tell you, are charged particles, negatively charged particles that exist around a nucleus. Now, these particles are subatomic particles. This is a diagram of an atom. Let me start there. This is a diagram of an atom. There's the nucleus, which has protons and neutrons. Protons have no charge. Protons have a positive charge. Neutrons are neutral and have no charge, and electrons have a negative charge. In an atom, you will have the same number of protons and electrons because atoms want their charge total, the sum of all of their charges, to equal 0. The fact that they want their charges to equal 0 is why atoms will bond together with other atoms, partially. Anyway, it's one of the main things that causes magnetism, and magnetism is the attraction between variously charged elements, etc. Very complicated, not going to go into there. But the important thing to know for this is that because the number of protons equals electrons, therefore the more protons, the more electrons. Now, what has the most or more electrons out of, pretty much any object? And the answer is, kind of obviously, metals in general. Metals have two characteristics that make them ideal for sending electricity through them. One, they have high density, which means that there are a lot of atoms of metal close together versus an air or a gas like xenon, and they have more electrons. I'll explain why more electrons is helpful. First off, though, why it's important to have more electrons. First off, though, there are elements with a high amount of electrons, like xenon, that are gaseous. And because they're gaseous, they are far apart from each other. Versus metals, and what we call metals, are packed tightly together in comparison to gases. They are just solids. Now, here's a quick diagram of what's happening when electricity flows. You have the nucleus of your metal, which in this case is iron, or pretty much anything. You have your nucleus, you have your electron valences, first, second, third, fourth, etc. And what happens is when you have more electron valences, when you have more electrons, you have more electron valences. And when you have more valences, the electrons are actually farther away from the nucleus. And because they're farther away, it's easier for them to be shared or sent to another atom. And the flow of electricity is actually the electrons from one bit of iron being pushed onto the electron valence of another bit of iron, which then causes that iron to push more electrons down. So while the iron itself never changes how many electrons it has, because this is instantaneous and this is instantaneous and doesn't take any time to happen, you do have a flow of energy. Now, the amount of energy that needs to flow through iron, through specifically metals and iron, is rather low because they are tightly packed together, and because they have a lot of electrons, and therefore the electrons are the farthest out electrons are farther out, because electron valences stack. So yeah, because they're close together, and because the valences, they don't really intersect like this, but since their valences are close together, you're able to have electricity flow through them easily. Now, why it's important to know all of those little bits is because electricity will flow through you. It will flow through, it'll also flow through air, even though air is a gas. However, it requires a whole lot more energy for it to flow through air than it takes to flow through metal. Electricity specifically is the flow of electrons that we can use, and we can use this flow to do work. Now, in order to understand how we use it to do work, let's consider a water wheel. There's water flowing past the water wheel, and the water wheel takes some of the kinetic energy from the water and uses it to spin the large wheel, which generally goes inside the building that the water wheel is attached to, and grinds up, and uses that energy to move a grindstone, which grinds up cornmeal or something, but that's not important. What is important is that you have something that's flowing and isn't used up in the process, but the energy is transferred from the flowing material to the water wheel. So the water energy flows to the water wheel spins, that's used to do something. Electricity acts in much the same way. We never actually get rid of electrons, but we do get rid of the energy potential of the electrons. Now, water is a really good thing to talk about because everyone understands how water flows. Sorry about that. So we're going to talk about how we talk about the flow of electrons. Now, there's two ways that it can flow. The first way is hard, and the second way is lots. Now, these are two variables that change depending on what exactly is pushing the electrons or water, but we talk about the flow as how hard it's flowing and how much is flowing. Now, specifically, we talk about an equation that is referred to as Ohm's law. I'm out of my pre-made ones. So what is Ohm's law? For anyone who already knows a little bit about electricity, you'll know that Ohm's law is V equals IR. We can interpret V equals IR as voltage equals amperage times resistance. Now, let's talk about specifically voltage. So, voltage is how hard your electrons are flowing. You'll hear things like a 9-volt battery, and what that battery can do is it can produce a push of 9 volts. Specifically, what a volt is a little bit difficult to explain, but it's easy to understand that it's just how hard the electrons are flowing. Yeah. So voltage is how hard they're flowing. I have different power sources have different voltages. Like a AA battery, for example, is 1.5 volts. A AAA battery is actually also 1.5 volts. And so are C and D batteries. In order to understand the difference between those batteries, you have to understand the other part about flow. And the other part is what amps are. Now, amps are current. They're how much or how many electrons are flowing. So, the reason why it's important to understand that is because the total amount of power that is going through the total amount of power that's going through the circuit is much more directly related to how many amps are flowing than how many volts it's flowing at. The difference between a C battery and a AA battery is simply how many amps of power total it has. We talk about how many total amps something has as amp hours, because it's how many hours it can produce a certain number of amps for. I have a battery here that says on it 3,000 milliamp hours, which means that it has the ability to put out 3 amps for 1 hour, which means that it can put out 6 amps for 2 hours, and on and on and on. So it could do 12 amp, wait, sorry, not 6. 1.5 amps for 2 hours and 0.75 amps of power for 4 hours. Sorry, I got my math wrong. Now back to Ohm's law. V equals IR. This is important to know because it explains why you need voltage, why you need it to be pushing harder. Resistance happens whenever you have a load. Resistance happens whenever you have a load. I'll explain what a load is in a second. Amperage is, like we've said, how many electrons are flowing, and voltage is how hard those electrons are flowing. One important thing to notice is that you can rewrite V equals IR as, where I is amperage, R is resistance, V is voltage, as V over I equals R. So if you know the total resistance of something that you build, of a circuit that you build, and I'll get to circuits in a minute, if you know the total resistance, you can find the voltage if you have the amperage, or you can find the amperage that will be required if you have the voltage in order to go through the entire thing. I'm going to pause there.